addition to the while loop and the until loop, there's also a third loop structure that's called a for loop. So let's keep modifying our script 7. Um, First, let's add a few comment lines. So you can start a comment line by using the pound sign. Pound sign. You can put a one or so this called a while loop. If you don't want to just use one pound sign to denote a particular section, you can use like a more than one pound sign to denote a particular section. For example, here I'm using 4 pound sign at beginning and after. And then we have the until loop. That was the previous example that we have looked at. And now let's add another section. That's the for loop. So we're still going to compute the summation of the first 5 even numbers. So let's still set eSum equals to 0. We'll set it back to E0. Now for the for loop, we don't really need a loop count. We don't really need a loop count. All we need is some kind of variable. Let's call it IVAR or whatever name that you want to pick. You can use any kind of name, and then specify the possible values, all possible values for this IVAR to take up on. And we would like to have the 5 even numbers, first 5 even numbers, 2, 4, 6, 8, 10. So IVAR is going to take 2 for the first iteration, and then it's going to take the value 4 for the second iteration, and then it goes on. So that's sort of the possible values for IVAR in this kind of list. And this list, the numbers, the elements in this list are separated by space. And then the loop body, I'm gonna do eSum equals to still backtick expr. I'm gonna take the existing value of eSum plus. All I have to do is to add IVAR now, because what I want is to add the numbers for the first 5 even, add the first 5 even numbers. And IVAR is going to be the first 5 even numbers. It's going to take values inside of these 5 even numbers. And then that's it. That's it. All we have to do is to done. Then that's the loop body. If you would like to echo the result, eSum equals 2, and then eSum, we can compare the result with the two previous, the result from the while loop and the until loop. And as you can see, all their results are identical, so it means that it is correct. So that's one way of writing the for loop. And there's also another way for writing the for loop, which is by specifying the starting value, the ending value, and also the stride. Because the IVAR, the values that the parameter, the variable IVAR is going to take up on, has a certain regular pattern. So this allows us to use the starting value, the ending value, and also the stride to specify the range, or to specify the values that IVAR can take up on. So now let's comment out this line and write it in a different way. So IVAR in, now let's use a curly bracket, a pair of curly bracket. We're going to specify the starting value, 2. And then dot, 2 dots. So that's the starting value. And then followed by the ending value, 10. And then dot, again, followed by the stride, which is the number, the value that you have to skip, that you have to add. So it's going to be 2. So it means that it's going to go from 2 to 10 with a stride of 2. And this syntax will give you exactly the list, the same list as displayed here. So it's going to start with 2, and then add 2 to the 2. Then it's going to be 4, and then add 2 to the 4. It's going to give you 6 until it reaches 10. So this syntax is actually, these two lines are actually equivalent. But if you have a large number of values, if the IVAR can have lots of values, this kind of syntax is shorter, is a lot shorter. Suppose you have to add the first 100 even numbers together, for example. There's no way for you to like type 2, 4, 6, 8, 10, and then 12 to type like 100 even numbers on a script. But this syntax allows you to do that. Starting from a value, end with a value, and then specify the stride. and it's gonna give you exactly the same result. As you can see, still gives you 30. That's the second way of writing the for loop, by specifying the starting value, the ending value, and also the stride in a pair of curly brackets. There's a third way for writing a for loop, which is by replacing this uh, this uh, this uh, this pair of curly brackets with an array actually. So you can do a for IVR in, and then the elements in an array, all the elements in an array actually. So before you can actually do that, you need to define an array variable. So AVAR is the array variable, just like what we did before, 2, 4, 6, 8, 10. So that's gonna define an array variable and assign initial values to the AVAR, to this array variable AVAR. So all those different elements are separated by a space. And then what you can do is to for IVAR, and then let's comment out these curly brackets, but replace it with something that's representing the entire AVAR star. So if you do echo this particular segment, this particular code, it's gonna display the entire array with all its elements being displayed. But if you do for IVR in this range, this representation of all the elements in this AVR array, then IVR is going to loop through each of the elements inside of this array, and it will certainly give you exactly the same result. As you can see, the last number is still 30. That's sort of a third way for writing a for loop. That's by using a array to define the range, or to define all the possible values that the iterator, the IVR, can take up on. There's also a fourth way for you to write a for loop, and this fourth type of writing is similar to C language actually. So we can just comment out this line. We want for this type of for loop, you don't really need an array. We comment out this line, and then we can define our for loop by using this double parenthesis, and inside of it we define the variable and initialize it to whatever value that we want to initialize it to. So I'm gonna do IVR equals to 2, and then I'm gonna do IVR smaller than or equal to 10, and then IVR plus equals to 2. So if you have used the C language before, this type of syntax actually means IVR equals 2, IVR plus 2. So you are actually adding 2 to IVR, this parameter IVR, and then assign the result back to IVR. And let's see what this particular syntax is gonna do. Again, it's gonna print out 30, so that's still the correct number. So basically, you have these 4 different types of ways for writing a for loop. You can give a list of all the possible values after the in parameter, after the in keyword, I mean. Or you can replace this list with curly brackets that's specifying the starting value, dot, ending value, and the stride. That's a second way of writing a for loop. And then there's a third way. You specify an array first, and then allow the iterator IVR to go through every element inside of this array by using this syntax. And then you have a fourth way, the last way for writing that. It's more like a C language, but you have to remember to use these double parentheses, and then you specify the initial value of the iterator, the ending value of the iterator, and then the stride. So the increment, every time, for every iteration, you want to increment IVR by a certain number, and that number for this example is 2. So basically, you have these 4 different ways for writing a for loop. The range of the for loop doesn't have to be limited to just the numbers. It can be a list of files, for example, or a list of string, or a list of anything. So let's look at how we can actually use the for loop to process a list of files, for example. For loop file. I'm still modifying the script7.sh file. So let's try to construct a list of files by using an array. But this time I'm going to use the backtick AOS. I'm just going to list the current directory, my current directory, which is home poaching temp, and then AF list is going to be an array that's composed of file names basically. So once I have this list, I can do a for loop for f in, and then followed by AF_LST start. That's all the elements inside of this array. And I'm going to do what? First let's just echo. Let's just echo the content of f, and then let's just done. And let's see what's going to happen. So it's going to these esum equals to 30 were from previous examples. We had a while loop, we had a until loop, and then we had 4 different types of for loops. And then starting from here, it's all about the files that's under the current directory, all the files under the current directory. So you can sort of see all the files. Now suppose we want to make a backup of all the files. Want to make a backup of all the files in a directory that's in the parent directory. Let's try to make a parent directory. We can just use a command mkdir dot. Let's call it backup. So I'm making a backup directory, a directory called backup in my parent directory, and then I'm gonna just copy. So inside of the loop, I can just copy. I'm gonna force the copy. So if there's names with the same name, there are files with the same name, I'm gonna sort of overwrite the existing files. I'm gonna copy, and then I'm gonna use the file name that's stored in f2 dot backup, and I'm gonna copy it into the same file name. So this will allow me to copy every file that's in my current directory to another directory, which is called backup. And this backup directory is in my parent directory of the current directory. So let's see what's going to happen. So let me show you what my parent directory actually looks like. It doesn't have a backup directory for now, but after I finish running the script7.sh, it's going to have a backup directory in my parent directory. Backup directory, that's in my parent directory. And then inside of the backup directory, it's going to contain all the files that I have in my current directory. And you can see exactly the same set of files. And if you want to do a diff to look at if there's any difference between, for example, script sandbox.sh in my current directory and the version that's in my backup directory, it's exactly the same actually. So that's one way. That's one of the ways for you to actually. I'm going to delete my backup directory. One of the ways that you can use your for loop to automate a certain task in your file system. And let's still go back to the script itself. So there's some kind of a simplification that we don't really have to. For example, we don't really have to define an array first. We don't really have to. We can actually comment out this line and replace this part of the. Replace the range with this command, and it's also going to work. So basically, AOS dot slash is going to list all the files that's under the current directory, and then I'm actually enclosing the result of AOS dot slash within a square parenthesis, and then appending it, prefix it with the dollar sign. So this particular syntax is going to have exactly the same effect as using this particular syntax by using an explicitly constructed array. You can think of it as constructing an array on the fly. So AOS dot slash enclosed in a parenthesis, you can think of it as constructing a temporary array. Actually, you are not sort of storing it into a variable, but essentially you are actually constructing an array of file names on the fly, and then the dollar sign in front of it is just for you to obtain all the results. So that's stored in that temporary array. You can think of it like that, and then it's gonna give you exactly the same result actually. So if I still run it, and then if you look into the backup directory in my parent directory, then it's gonna have exactly the same set of files. So that's how you can actually use a for loop to process files. In this particular example, this process is just a copy command. There's another simplification that you can use if all the files that you are listing is just under the current directory. If it's under the current directory, then you can use star. You can use star to represent all the files or a list of the files under the current directory. So in this case, it's gonna just loop through all the files in the current directory. So if you execute script 7, it's gonna give you exactly the same result. So there are different ways for you to actually loop through all the different files, at least for in the current directory. But you cannot use this syntax for files that's not in the current directory. Suppose if you want to list, suppose you would like to list all the files that's in a certain directory, say for f in lsvar. So suppose you would like to list all the directories, all the files under the directory var, then you have to use this kind of syntax. You cannot use star anymore. Star is just for representing all the files in the current directory. So if you still would like to use the star instead of this kind of explicit listing of a certain directory, you can first switch to that directory first. You can switch to that directory, and then you can use for f in star. So that's gonna allow you to list all the files in that particular directory. And after you are done, after you have finished processing all the files, you can switch back to your home directory, for example. And that will allow you to sort of use the star to represent all the current files in a specified directory. Sometimes you may want to write a infinite loop. Infinite loops are sometimes useful. Suppose you are trying to monitor the status of a certain file, or if you are trying to monitor the status of the network traffic, that kind of thing. You want to keep the script running and do some action if the status of the network or the file has certain kinds of changes, that kind of thing. So an infinite loop could be useful. So let's try to write an infinite loop. And this kind of infinite loop can be easily implemented using the fourth way for writing a for loop that's displayed here. We looked at this example. This is a sort of a syntax that's very similar to the C language actually. So if you want to sort of change it to an infinite loop, you can just do for and then space semicolon, space again semicolon, and then close it with two parentheses, and then you can just do. Let's echo some arbitrary string, and then done. And then this loop is gonna keep executing for indefinitely. It's gonna execute forever. So as you can see, it's just gonna keep printing out welcome for like the eternity. If you want to interrupt the iterations, you can use Control C, hold down the Control key, and press C on the keyboard. Then it's gonna interrupt the iterations. And suppose you don't want to use Control C, but you want to break the loop on a certain condition. So if a certain condition actually is satisfied, you want the loop to stop. So let's do a simple example. Let's define a number. Let's call it IVR and initialize it to 0. Now let's try to increase IVR inside of the loop. So essentially IVR becomes the loop index, even though you did not specify any kind of loop index in the for statement on this line. But by defining an IVR and increasing it, you essentially are defining a a loop index actually, +1, suppose. So here I'm actually increasing IVER by 1 for every iteration. So now let's define a condition. So here I have to introduce the conditionals. So for any kind of computer language, you have two types of flow control. One is called loop, the other one is called conditionals. It allows you to specify which branch of the code you want to execute. And here we can use the if statement now, the if keyword. The if keyword is followed by a pair of square brackets, and inside of the square bracket you can specify any kind of condition that you want to use. So suppose I want to use IVER as a condition. I want to compare IVER with say 10. So I'm going to compare IVER with 10. If IVER is larger than 10, then this condition becomes true. And if this condition becomes true, terminate the square bracket with a semicolon, then break. And then you can close a if block by using fi. So as soon as you finish typing fi, type the tab key, press the tab key, it's going to automatically indent the keyword to the right position. So now you're actually comparing IVER with 10. If it's larger than 10, suppose IVER has a value of 11, then it's gonna break. Break means I want to stop the loop now. I want to sort of break out the loop. So a break is gonna take you to the end of the loop. So it's gonna stop the iterations. So let's give it a try. Let's see what's gonna happen. So this sum is from previous examples. It's gonna print out a welcome for like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's gonna print out a welcome for like 11 times, and then it's gonna stop. So you can sort of see how you can actually use a if statement to introduce some kind of condition. But don't forget to put a space behind the left square bracket and a space in front of the right bracket to make sure that this sentence actually the syntax is correct. Otherwise, the syntax won't be correct. So instead of we do welcome IVER, for example. We can do welcome IVER. So it's gonna print out the loop index. So IVER starts from 0 and then ends with 10. Now let's try a different syntax. The if statement allows you to introduce just one condition, and then that's something that you can sort of easily do. So, but it also allows you to have another branch of execution, which is specified by the keyword else. Type the else, the word else, and then tab. Press the tab key, it's gonna automatically align. Let's try a different statement that's called continue. What's actually the purpose of continue? The purpose of continue is to jump to the beginning of the next iteration. So let's move this echo command to the end to after this if else block. If else block. So it's gonna execute if IVER is larger than 10, then it's gonna break it. But if IVER is actually smaller than 10, it's gonna jump to the beginning of the next iteration. To the beginning of the next iteration, and at the beginning of the next iteration is actually assigning a value. So in this particular example, this echo command is never going to execute actually. So in this particular behavior, the echo command will never execute. As you can see, you don't see any printout of the welcome. This is because of the continue command. This continue actually brings the workflow, the flow of the execution back to the beginning of the next iteration. So it's never going to come down to this echo command. And the break, as soon as IVR is larger than 10, it's gonna break the loop and jump to the done. So it's gonna skip this echo command. So this echo command never gets executed. So that's what we call break and continue. They have different meanings. Break is for jumping to the end of the loop from inside of the loop, and continue allows you to go to the beginning of the next iteration of the same loop. Let's look at another example of the break and continue statement. So break and continue, and let's try to understand it better how these two statements are different. So let's do a for loop IVR in. I'm gonna use this kind of syntax. So I'm gonna specify the starting number, that's 0, and then the ending number of 10. So if your stride is 1, then you don't really have to write the .1. The default stride is just a 1. And then I'm going to do echo IVR, and then done. So this is a very simple for loop. It's just going to print out IVR from 0 to 10. So suppose I want to do script 7.sh, then it's just going to print out 0 to 10. Suppose I want to get rid of all the printout of odd numbers, but I want to keep all the printout of even numbers. So how am I going to change my script? So I'm going to add a condition here. So the conditions that I'm going to add is basically to compare, is to find out if it is true that this number is even or odd. I'm going to use a backtick and expr. I'm going to take the value of IVR and then modulo 2. And if this number is 0, then it means that IVR is an even number. And if this number is not equal to 0, then it means that it's an odd number. So I'm going to compare it with 0. And if it is not equal to 0, which means that IVR is an odd number, so what I'm going to do, then I'm going to do continue. And then that's my if block. That's it. So if you look at the logic of this particular if block, IVR is going to keep changing from 0 to 10. But if IVR happens to be an odd number, it means that this expression modulo 2 does not equal to 0. Then I'm going to do a continue. Continue is going to jump to the beginning of the next loop, to the next iteration of the loop. So it's going to skip this echo. It's going to jump directly to the beginning of the next iteration, which is doing this comparison again, which is actually increase IVR, and then do this comparison again. But if it is an even number, then this continue is skipped because this condition is false. So it's not going to execute this continue statement. It doesn't. If it does not execute the continue statement, the flow of the execution is gonna go to this line. It's gonna echo this particular variable. So this continue allows me to skip the printout, to skip this line for all the odd numbers for IVR. And let's try to find out if that's true. So it starts from 0 to 4. It's indeed printing out all the even numbers. So continue allows me to sort of jump directly to the beginning of the next iteration of the loop and skip all the commands that's sort of after this continue statement. Now let's change continue, this continue statement to break and see how the behavior of the script can change. So if we change the continue to break, then it's going to break the loop the first time IVR actually becomes an odd number. So let's IVR actually started with an even number, that's 0. But as soon as IVR becomes 1, then this condition becomes true. If this condition is true, it's going to execute this command. It's going to break the loop. So the only thing that this script is going to do is to echo 0, and then that's it. Then this script is finished. So let's see if that's the expected behavior. And you can sort of see it prints out 0, and then the script has stopped. It's not printing out any of the numbers. That's because of the effect of the break statement will actually jump out to the end of the loop. It's not jumping back to the beginning of the next iteration. It's actually jumping to the end of the loop. It's jumping to done. So that's why you just see one printout of IVR equals to 0, and then that's it. So that's sort of the difference between a break command and a continue command. You can also nest loops. So a loop, you can write a loop inside of another loop. So you can nest loops by several levels actually. So here we have just a one level loop. It's just a one for loop. But we can actually nest another loop inside of a loop. So let's do some examples about nested loops. And I'm gonna comment out these lines so that it does not print out anything that's gonna distract us. So, but this time I'm gonna use two loops. I'm gonna do a for IVR in from 0 to 2, and then I'm gonna write it like that, and then I'm gonna write another loop with the loop index JVR also within the range from 0 to 2, and I'm gonna write the looping this way. So by default it's gonna echo IVR and also JVR. But I'm also gonna build some conditionals into it. I'm gonna write an if statement, and this if statement is gonna look at the values of IVR. So if IVR actually equals to 1 and JVR, the value of JVR equals to 2, then I'm gonna execute some statement. Sorry, I forgot the semicolon here. I'm gonna execute some statement. So if you look at the conditionals, it's slightly more complicated than before. So I'm comparing the value in IVR with 1. So if IVR actually equals to 1, then the condition for this part of the conditional becomes true. Otherwise, this part of the conditional is false. And then this is the second part. So I'm comparing JVR with the number 2. Sorry, I forgot the number 2. So I'm comparing JVR with the number 2. So if JVR has a value that's equals to 2, and then this part becomes true. This part of the conditional becomes true. Otherwise, this part of the conditional is false. And then these two conditions, these two comparisons, are actually connected using -a. So in a shell script, -a actually means and. And you can sort of imagine there's also another symbol that's O. That's -o. So if you do -o, -o actually means O. So and means what? And means the whole conditional, the stuff that's inside this square bracket is true only when both conditions, both comparisons are true. So that means and. So if this is true and also this is true, then the whole thing inside of the square bracket is true. So if any of those any one of those two conditions is false, then the whole condition inside the square bracket is false, and you don't get to execute whatever the command is. So now let's try the command break. Let's try the command break, and let's see what's gonna happen. And then fi, and then done to close the inner loop, and then done to close the outer loop. So we have two nested loops. This is the outer loop. This is the inner loop. And inside this loop, we are echoing both values. And then break, we have a conditional that's gonna be true once these two conditions are both true. And then it's gonna break. So let's see what's gonna happen. Script 7.sh. So it's printing out. So IVR changes from 0. And then JVR from 0 to 2. So that's sort of the when IVR equals to 0 and JVR changes from 0 to 2. And then this is again IVR equals to 1, and then JVR goes from 0 to 2. And then IVR equals to 2, and then JVR goes from 0 to 2. So it looks like you didn't actually have a break statement at all. So let's change the break statement a little bit. The break statement actually takes an argument. This argument is telling break to jump out of the loop inside of a nested loop. So 2 actually means that you want to jump out 2 levels of the nested loop. So it means the default is just a 1. The default is just a 1. If you have just a 1 loop instead of the nested loop, just a 1 level of loop, then break 1 is just going to break out that loop. But if you have 2 levels of a nested loop, you have 2 falls together, you can use break 2. And then it's going to bring you down to this done. It's not this done, but to this done. So break 2 is going to, once it encounters this line, it's going to take you down here. And then it's going to finish executing. Now let's look at what's going to happen for script 7. So IVR still is 0, and then JVR goes from 0 to 2. And now IVR equals to 1. J goes from 0 to 2, and then that's it. It has finished executing because the break 2 command. Once IVR equals to 1 and JVR equals to 2, the conditional becomes true. The conditional in the if statement becomes true. And then it's going to break 2. Break 2 means that it's going to take you down to the second done, to the out loop done, and then it's going to sort of break the entire execution. So now let's try to understand why break without the parameter 2 is not really having any effect. So when IVAR equals to 1 and JVAR equals to 2, it's going to break. Yes, it's true. It's going to break. It's going to take you to this done. So this loop is done. But this is sort of the inner loop. J has a value that goes from 0 to 2. So when J actually equals to 2, that's exactly the last iteration of the JVAR, this inner loop. So that's why this break is not really having any effect. Because when this condition is satisfied, when you break, this inner loop has already finished. There's no reason for you to actually. But if you actually change the condition from IVR equals to 1 and JVAR also equals to 1, and then you're gonna see the effect. So when I equal to 0, nothing happens. When I equals to 1, J equals to 0 is fine. JVR equals to 1 is also fine, but you don't see any printout for IVR equals to 1 and JVR equals to 2. You are missing one line. It's 1, 2. And then the loop actually continues when I equals to 2 and J equals to 0. So you are missing one number here. So that's why you are having a different effect for break and break 2. So if you have break 2, then it's gonna stop the entire loop, both the inner loop and also the outer loop. It's gonna jump directly to this done. And of course, you also have continue 2. Continue also allows you to specify a parameter that allows you to jump to the next iteration of the outer loop, because you have 2 loops here, 2 nested loops here. So continue 2 is going to allow you to jump to the beginning of the next iteration in the outer loop. Now let's look at the conditionals in more detail. So far, all our conditions are specified using numbers. We're comparing numbers basically. But you can actually do more testing. Testing on strings. You can test on files, directories. There are lots of testing or lots of kind of logic operations that you can apply, not just on numbers but also on strings, files, directories, that kind of thing. So let's try to write a new script. Let's call it script 8.sh, and that's sort of my shebang line. And then the kind of let's do string comparisons first, and we're gonna look at how to test if two strings are equal to each other. That's this particular equal to sign. And this particular syntax is quite confusing if we have used the C language before, because in C language a comparison or a test for equal to is actually two equal sign next to each other. So if you have just one equal sign, people in computer language often think it's an assignment operator instead of a comparison operator. But for Bash shell, this is actually a comparison test equal to the test for strings. And also you have not equal to. Not equal to is just an exclamation mark followed by equal. And then you have -n. So -n is to evaluate whether the string length is greater than 0. And then you also have -z. -z is to evaluate if the string length is equal to 0. So these four operators can be useful when you try to test the strings. Uh, so string comparison. So let's try to construct some strings first. Let's call it str1. Let's assign str1 some kind of a character x, y, z, say, and then str2 equals to x, y, say, let's give it a 0, x, y, 0, and then let's see if how we can actually use these two examples, these two strings to do some testing. So if I'm doing a conditional, so if str1 equals to str2, then sorry, then I'm gonna echo str1 equals to str2, else. So here I'm actually using an else echo str1 not equal to str2 fi. So of course str1 is not equal to str2 and it's supposed to print out this particular line. But let's see if that's the expected behavior is script a.sh. So xyz not equal to xy0. Right. Of course, you can change it, right? You can change the second one to xyz also, and then it's gonna switch to the first print out xyz equals to xyz. So that's how you can actually test if two strings equal to each other. Let's change it back to xy0. That's for evaluating if two strings are equal to each other. Of course, you can also change the logic, reverse the logic. str1 not equal to str2. Then echo what? Echo str1 not equal to str2. That's the opposite of the logic, right? And then else, but this time it's gonna echo str1 equals to str2. fi. The error that I had was that I missed a space in front of the second square bracket. So this time it's supposed to print out the correct result. So this is from the first if block. This is from the second if block. So in the first if block, I was testing for if these two strings are equal to each other, and in the second, I was testing for if these two strings are not equal to each other. So that's two ways for you to do similar kinds of testing. And now let's look at -n. So the way that you can write this statement is -n str1. If this is true, then the length of str1 is not equal to 0. Then you can echo str1 has length greater than 0. else you can echo is length equal to 0. And then fi. So xyz has a length greater than 0. That's of course true, right? And you can also test it using dash z. Suppose if you want to write if dash z str1, then you should use the print out the length has a length equal to 0, right? Else you need to print out this line. So it's sort of the opposite of the logic that we have. Fi. I misspelled the word, so that's why I was getting an error message. So both of them should print out xyz has a length greater than 0, right? Of course, it's dash n and dash z. And there's also another way for you to test if a string has 0 length or if a string is empty or not, which is by testing the string itself. So if you actually include the string itself inside of the square bracket, you can also test if a string is empty or not. It's not empty. It's not empty. Else you can echo str1 is empty. Fine. So it's telling you xyz is not empty. You can also apply tests on files and directories. So for example, we can test to see if a file actually exists in the current directory or not. Let's write a new script. Let's call it script9.sh. And then, so let's define a file name. So f equals to, for example, test. And then we can test if this f file indeed exists by using the dash "-e". So dash "-e" represents for existence. So let's see if this particular file name actually stored in f, if it exists in the current directory or not. Then I'm gonna echo f file exists. Else, otherwise, I'm gonna echo f file does not exist. And then I'm gonna fi. Let's gonna close it. Let's just make it executable. No, it's 9.sh. Script 9.sh. Then it's gonna tell me test file exists. If you do an ls, you can sort of see test indeed exists. This is a existing file, so you can sort of test to see if a file actually exists. The thing that you can test for is not just the existence. You can test lots of things actually. So dash "-e" is for testing if it exists or not. And then you also have a dash "-d", which is for evaluating if the file is a directory or not. And then you also have dash "-f", which is for evaluating if the file name actually is a file, is a file or not. And then you also have dash "-r", dash "-w", and dash "-x". These three options are for testing if the file or directory has read, write, or execution permissions. And then you also have a quite useful test that's dash "-s". And dash "-s" is for testing if a file exists or not, and also has a length greater than 0. So let's, for example, if let's change it. Let's change it to ABC. Let's change the file name to ABC. And then let's add another condition. If dash "-s", f then echo if file has none has length greater than 0. Else I'm going to echo if file has 0 length fi. So now let's give it a try. Script 9.sh. So ABC file exists, and then ABC file has 0 length. So let's do a long listing of ABC. Yes, it does have a 0 length. So you can sort of test to see if the file exists or not, and then you can sort of find out if it has a 0 length or not. And the kind of options that you can test is not limited to those that I listed in my script. And if you Google, you can often find you can also find lots of other options. For example, for testing the ownership of a particular file, that kind of thing. So you can also apply tests on files. So the logics or those tests on files can also be combined into more complicated tests. For example, if you want to combine something, so -s f if f is actually has non-zero length, for example, has a larger than length, and for example, and -r f. So basically, you are testing for if the file has non-zero length, large of length that's greater than 0, and also if the file is readable, then you print you echo. For example, maybe you can do a cat if else you can just echo f is not readable or has 0 length, that kind of thing. Fi. So ABC is not readable or has 0 length. It's not sort of echoing any stuff to it, so it's not actually printing out the content of the file. But if we change it to a different file, then it's going to print out. It's going to do a cat. It's going to cat. So news.txt file exists. It has a length greater than 0, and then it's going to print out the content of that particular path. So that's how you can actually combine tests on files together to produce a more complex conditional. You can also combine conditions using the -o. -o allows you to combine two conditions using or. So if suppose I define another file, f1 equals to, for example, test, and then I'm going to test. I can test, for example, if f1 is readable, if f is readable, or -o. Again, if f1 is readable, then I'm going to echo f or f1 is readable. Fi. So this is -o allows you to combine two conditions as or. So let's give it a try. So news.txt or test is readable. So let's do a long listing, news.txt and test. So both of them are actually readable. So both of them are actually readable means what? Means this condition is true. So it's a -r f is true. So it's a -r ABC is true. So ABC is readable. And then -r f1, that's -r test is also true. So if this is true and this is also true, so -o actually means or, then the result is true. So suppose we change the permission. we subtract R from all users for test, for example. And then let's do a long listing of test. Now our test is not readable by any of the uh, by anyone. Then let's still run script 9. News.txt all test is readable, which means that test, even though test is not readable, but news.txt is still readable. News.txt is still readable. So in addition to -a, which means and -o, which means or, there's one more logical operator that's kind of important, which is the negate operator or exclamation. This exclamation is going to sort of reverse the result of a test. So now if suppose I want to test the readability of f has a value of news.txt, which is f has a value of news.txt, so it's going to test the readability of news.txt, this particular file in my current directory. And if it's readable, if the file is readable, then this condition is going to be true. But if I put an exclamation in front, it's going to negate whatever result it's going to be returned by this particular comparison. So if f is indeed readable, this is going to be true. This part of the logic is going to be true. But if you actually put an exclamation in front of the true, then the whole thing inside of the square bracket becomes false. So what am I supposed to sort of put in here? What I'm supposed to echo here? So f is or is not readable. So if I come to this particular line, which means that this condition is true, the whole thing, if the whole thing is true, then the stuff after the negate operator is supposed to be false. So -r f is supposed to be false, which means f is not readable. And then fi. And let's give it a try, see if news.txt is indeed readable or not. Let's do a long listing of news.txt. It's not readable based on the current permission. So now let's run script 9 and see if it's printing out the correct logic. So it is telling me news.txt is not readable. So that's sort of the last condition that we are sort of testing. So basically you have three operators that you can, logical operators that you can use for combining logics together. So -a means and, -o means or, and then the negate. Negate is going to reverse the result of the testing. That's sort of behind the exclamation mark. The if statement also has, in addition to else, it also has another syntax that's called else if or elif. So let's define a I variable that's equals to say equals to 2, for example, and we can do some testing. For example, if IVAR is smaller than, if IVAR is smaller than LT, for example, if it is smaller than 1, for example, then we can echo IVR is smaller than 1. elif. So elif, different from else, elif allows you to specify one additional condition, for example. So here you are testing if IVR is smaller than 1. So if this condition is not true, then the command that's following if is going to be skipped, and then it's going to do this comparison, do the comparison inside of the elif square bracket. So it's going to compare, for example, if IVR is it going to be larger than 10, for example. So if this condition is not true, which means IVR is larger than or equal to 1, for example. If it is larger than or equal to 1, then it is possible that IVR could be larger than 10. Then you could echo IVR is larger than 10. And then you can you can do multiple AOF without any kind of a problem. So we can put IVR if IVR is not smaller than 1, it's larger than or equal to 1 and also smaller than 10, or smaller than or equal to 10. So it's between 1 and 10 then. And then you can sort of test if it is a sort of larger than 5 or so, something like that. And then you can echo IVR is between 1 and 5. No, it's between 5 and 10, for example. Else, you can echo IVR is between 1 and 5, so FI. So you can actually build quite complicated logic using if, elif, and else. So this allows, so you can put multiple elif in your logic to account for situations that's not accounted for in the if. And for every other condition that you have not accounted for in if or elif, it's accounted for by the else command. So suppose we want to sort of read the input from the user, for example. If we want to echo, let's do an echo n, input an integer, and then read IVR, for example. I'm supposed to put a space between the 5 and the square bracket. So 8 is between 5 and 10, so it's telling me I'm entering a number that's 8. So let me sort of try another number here. Let me give like a 19 or something. So 19 is larger than 10, so it's telling me it's actually a quite logical comparison. So if else, and fi, that's sort of the conditionals that allows you to account for different kinds of situations. Suppose you have a quite large number of conditions, and writing lots of AOF becomes quite tedious. In this kind of case, you can use a conditional constructor that's called case. So you write suppose let's ask the user for some number. Again, let's ask some number. Echo input a number between 1 and 7. Input an integer between 1 and 7, for example. And then let's read it. Let's read it into I. Let's read it into II, for example. The case constructor allows you to sort of some kind of capability that's similar to the switch statement in C or C++. So case, you can sort of do II, test the value of II in, and then followed by lots of the conditions. So suppose it equals to 0, 1, or 1. So this vertical var in this case statement, it's equivalent to all, and then it's gonna print Monday, for example, and then semicolon. You have to end it with 2 semicolons. Actually, this is sort of different from other kind of statements or commands. So if it is a 0, 2 or 2, echo Tuesday. Again, semicolon. 0, 3 or 3, echo Wednesday. I'll just so either 0, So let's just use 4 now. I'm gonna skip the possibility that the user is gonna enter 0 for something, and then it's gonna echo Thursday 5, echo Friday 6, echo Saturday, and then 7, echo Sunday, and then you end. Um, but I also need to account for cases that's kind of a not between 1 and 7. So if user entered some other command, some other number, I should give user some kind of feedback. I should echo invalid number, and then you end the case by using exec, which is basically a spelling case in the reversed order. So this allows you to actually end the case construct. So let's give it a try. This input integer was from the previous example. It's asking me 10 is between 5 and 10. So now it's asking me to input an integer between 1 and 7. Let's give it like 5. So it's telling me Friday. Let me try it again. And then let's give it like a 1, for example. Monday, right? Then let's give it like a 7. Then it's telling me it's Sunday. So if you look at the construct of the case construct, it's a conditional that allows you to test on different kinds of possibilities. It's reading an input from the keyboard, from the user, and then it's going to test II and see if it equals to any of those integers. If it's not a match for any of the integers, it's going to go to this line. So suppose I try some value that's incorrect. Let's give it a 9 or something. Then it's going to tell me it's an invalid number. And if I try something that's 2 digits, for example 0, 6, it's telling me an invalid number. It's because of what? It's because I did not actually specify the 0, 6 option here. It's for Monday, Tuesday, and Wednesday I specify 0, 1, 1 or 0, 2, 2. But for Thursday to Sunday, I did not specify the 0, 4 or 4 option. 0, 4. If I add this option, or 0, 5, 5, and then 0, 6 or 6, and then 0, 7 or 7. So now let's do 0, 6 again. Then it's telling me it's a Saturday. So that's how you can actually use case to list a bunch of options and allow your input to be compared with all those options in a more streamlined fashion. One of the pitfalls is semicolon, the 2 semicolon that's after each of the line. So the reason that you need 2 semicolon is because you want to prevent the execution of the following commands. So suppose you entered, suppose II equals to 1, and then it's going to echo Monday. But suppose you don't have these 2 semicolons behind Monday, then it's going to keep executing the rest of the lines. It's going to go to Tuesday. Here's a short summary about what we have talked about so far about writing shell scripts. So at the beginning we talked about how to write a very simple script with a shebang line and some kind of echo command, and then we have to change the permission of that file by using chmod plus x to make it executable, and then we can just run that script just like an ordinary command. What I was telling you is that a script is just a combination or a concatenation of lots of commands, but you can also build lots of logic into it. You can use variables and that kind of thing. And then we talked about variables. We talked about 3 different kinds of variables. We talked about environment variables, which is set up during after you log in. So the system is going to set up a large number of environment variables, and you yourself can also define environment variables by modifying the .bshrc file. And then we talked about those built-in variables. Those built-in variables. Um, those built-in variables. Some examples are like those positional arguments, those command line arguments that you can sort of pass from the command line into the shell script itself, which are $123, that kind of thing. Those built-in variables, and then some of the built-in variables are kind of specified by the shell script system. For example, the $star, it's going to tell you, it's going to list the entire command line input as one string, that kind of thing. Those built-in variables. And then we talked about the user variables. So user variables, you can define a single variable that stores just one element, or you can define an array variable that can store a collection of items or a collection of stuff. Those collections can be numbers, strings, or combinations of numbers and strings. So and those array variables are quite flexible, and you have a bunch of utilities that's kind of related to array variables also. And you can access different elements of the array. You can get the length of the array, that kind of thing. It has a syntax that's related to arrays actually. And then we talked about different kinds of loops. We can carry out loops iterations using different syntax. We talked about the while loop. We talked about until loop, and then we talked about for loop. For the for loop, you can have lots of different syntax. In fact, we have like 4 different ways for writing for loops, and those loop ranges can be either numbers or arrays, or arrays of numbers, or arrays of strings, or even file listings, or a list of files and directories, that kind of thing. So it allows you to actually execute commands on a array of files, for example, that kind of thing. So that's loops. And then we talked about the conditionals. If, elif, else, fi. So that's a if construct. If a constructor, it allows you to use different kinds of conditionals. And those conditionals can include number comparisons, string comparisons, testing if a string is empty or not. And it can also contain testings on files and directories, see if a file or directory has certain properties or not. And then you have case. Case is another kind of conditionals. It allows you to test a certain input variable with a fixed number of cases, and those fixed number of cases can be quite large. You can sort of specify lots of different cases to account for different scenarios. So it's a quite preliminary introduction to shell scripts. We haven't discussed those in-depth topics. For example, functions. Suppose you want to sort of define a function using shell script, and then reuse those functions in later scripts, that kind of thing. It's also possible to define functions, that kind of thing. So basically, the shell script is a very capable programming language. It allows you to write very complicated programs using shell scripts.